demo. So I'm Matt Whitmer. I'm, as Doug pointed out, a solution engineer for Opengear. Been here a little over 4 years. My background is network engineering. I've been in network engineering field for just about 30 years. So I've pretty much run the gambit of networks. Today, our demo, we're going to go through, some standard network engineering scenarios, design, deployment, operations, and troubleshooting. We added a little bit of a twist with it, based off of what we did last year by adding a little bit of some agentic AI, as Doug pointed out, on top of our UDOP Opengear solution. So I think we'll have a lot of acronyms that we throw at you, and Doug kind of mentioned some of them. Some of them we're going to use today are the Lighthouse Service Portal. That's going to be part of our provisioning that we're going to do. We call that LSP. The Smart Management Fabric is SMF. We'll use that as well. Connected Resource Catalog, CRC, that's going to be basically our reference design or our inventory that we'll show. And yeah, those are the three ones that we're going to use. So part of our Opengear solution that we like about it and things we've shown in the past is the extensibility and flexibility of our solution. That's a foundational piece of Opengear, being able to do things that are just beyond just a regular console server. So, you use your imagination. It's essentially a compute as well as switch, router, and console server, your traditional type of console server. There's a lot of things you can do with it. And some things we showed in the past is being able to run iPerf. Here at TechField Day, we've done iPerf with it. We've run the Docker container to do Wireshark. We had a web UI, or actually, I think it was a Windows UI that we did some Wireshark analysis on. DHCP, Thousand Eyes agents, and a lot of different customized scripts that you can do on the platform. So just these next few slides are just kind of set the stage. So this is the high-level network architecture that we're using here for the demo today, as well as what we're doing here at Cisco Live in general. So what we're going to focus on today is the boxes on the left side where it says OG Lighthouse. That's basically what we're going to focus on. If you want to hear about the rest of our stuff, you could go see our booth. We have a partner there that we partnered with, SVA, that we can walk you through some of this other design stuff that we are doing as far as a demo. So this is our detailed network diagram. This is exactly what we're going to do here in the demo today, kind of show this. It's a little bit of a non-standard network diagram, and we'll kind of get into why as you see as we progress through our demo. So what is we have 4 operation managers, which we call OMs. We have a couple different flavors of OMs. We have Cisco routers, 3 Cisco routers, and then we'll have an ILO and then a PDU. This is basically what we're calling our reference design for this demo. So we have our CRC, what we call our Connected Resource Catalog. All these devices in the diagram are represented actually in this catalog, this connected catalog that we have right now. So we'll get more into this web app here in the demo. We just wanted to set the stage to show kind of what our reference design actually is. So the first scenario we're going to go through is design and deployment. And flipping to this slide here. So this first scene here is we're turning a network design into configuration data. Basically, you need a network architect or someone with some bit of a experience to actually create a design artifact, which in our case is a network diagram typically. So we typically have, our reference design like we showed. Well, now a company, or we're going to call them Acme Corporation, they want to add a rack to their Utah location. So the architect, he creates a diagram, orders the parts, and now as he has that artifact, he wants the diagram to represent, he wants to get that diagram, which represents unstructured data, into structured data, something that we can feed into our network design, and then pump out configuration data. So basically, here's the steps. The architect creates the diagram represents the data, The team wants to get that, the deployment team wants to get that into something they can use, some configuration data. So he uploads this app. He uploads his diagram into this app, which generates basically a JSON with all the configuration data that shows in the diagram. And then that data then is pushed to our inventory manager and is now part of the reference design.
What we're going to show you today is one facet of the application that we've built. And the idea here is that the earlier diagram that Matt just spoke to represents the existing network deployment, right? That's kind of the level set, the basic design that's deployed in the network. Now they wish to deploy a new rack, and that's depicted by this, this darker gray box over on the right-hand side here. So we've got LSP shown there, which is the cloud-hosted portal we use to enable automated enrollment of Opengear console servers into our central management system called Lighthouse. We've got an Opengear serial console server there, the OM, over in the right-hand side, and there's an additional Cisco router. So the network architect has created an updated diagram that includes those additional elements. So with the web application that we've built, we can take that diagram and we can convert that to structured JSON data. We're not going to go through that because of just in the interest of time, right? We want to really get to some more interesting things a little bit later, but we've got a screenshot of that function here. Everything that we're going to talk about today and everything that we're going to show you is real, it does work, and it's integrated, as Doug said, on top of the existing Opengear APIs and features and functions that we have in the product. So what we've done here is we've taken the updated network design, we've converted that to structured JSON data. You can see it listed over on the left-hand side there. And we have a button at the top of the application labeled Push to CRC, so push to the connected resource catalog. What we can do with that button is basically traverse the JSON document, extract all the pertinent information in it, and upload that to the inventory. Now, we don't want the AI, this is an AI-assisted application, I should say. We don't want the AI agent to hallucinate. We don't want it to make things up. We want it to only make use of factual information that it's able to extract from the diagram. And we did have some difficulties with that when we were putting this application together, but we've been able to corral that and get it to work in the way that we wish.
Okay, so now that we've had the architect, basically he uploads his design. We now have that in our reference design and our CRC. We can move into the next phase, which is we're going to stage it. So now we have we stage this at an integration lab essentially, so a VAR prior to sending it out to the site. So these are basic steps that basically go through. So step one, this guy he pulls all the equipment, cables it up, powers everything on. Step two, everything's powered on, everything's good to go. And this is where some of the things that we do as Opengear kind of enable this process. So once it's powered on, we have an operations manager device. In our case, it's an OM 1208 that is actually in the rack, that all the connected devices are managed by. So it reaches out, as soon as you power it on, it has an internet connection, it reaches out to LSP. And LSP, our Lighthouse Service Portal, basically it provides a way for you to have visibility for your assets for the Opengear devices, and also do some zero-touch provisioning over the cloud, over the internet. Once you connect up, you can set up a configuration bundle in the Lighthouse Service Portal. The OM reaches out to Lighthouse Service Portal, grabs its configuration, and then it automatically configures. So in the past, we had folks use USB keys or whatnot, or manually configure it, and there's some security implications there. And then if you have, hundreds of devices, hundreds of Opengear devices, that can be cumbersome. So this allows you to basically zero-touch provision just by turning it on and having an internet connection. And if it's cell-connected, same thing will happen. So let me kick this off. So once the OM gets its configuration, calls home to Lighthouse, then all the connected devices, something else we did is we hosted the configurations for the actual routers that are hanging off of it on the OM. So once the OM registers, gets its Lighthouse Service Portal enrollment, Lighthouse enrollment, then we kick off a ZTP process where now a Cisco router goes, grabs its configuration, and basically goes to the standard ZTP. You know, everyone's kind of went through that. So it's just a standard ZTP process. And then once that gets done, we can actually take those devices, we'll show this in there, we'll show this in the demo, is it'll automatically discover devices and then populate into our basically our inventory, our CRC. And then once you do that, you can run a diff. We have a diff utility that we set up that you can kind of see the difference between the network design and the reference design, and you'll be able to see that those devices will actually automatically update. And then once that's done, you ship it to site and they can run the process again.
Very good. So what we're showing in this screenshot, this is a list of the assets that are in the reference design. This is data that was extracted from the network diagram. And this list are the actually discovered assets. So we have an application that runs on the Opengear console servers, and it reaches out using passive discovery techniques like LLDP, CDP. It can do serial port based discovery as well. We did some things with ARP, but we took that out because ARP's just not terribly useful. You don't get very much back from that. But it does give you a mechanism to discover the actually deployed set of devices that are in the network. And then you can make a comparison between the two, right? So there's your, in this slide, we've got the reconciled devices, which are assets that are in both the reference design and they're actually discovered in the deployed network. We've got 2 or 3 extra devices there. Not really quite sure why those are there, but they're there. That's maybe something that the network administrator should take a look at. And we've got 2 missing devices. These are the devices that were in the updated network diagram, but they've yet to be enrolled into Lighthouse, and the router has yet to be provisioned. So this is a screenshot of the Lighthouse Service Portal. We just put this in for context so that the audience can get a sense of where this fits. This is a cloud-hosted service. Customers can log in here. They can see their purchase assets, the serial numbers, and they configure the information necessary so that the console servers can automatically enroll into their on-prem Lighthouse system. Okay, so now I think we're back to you, right?
Yeah, so this screenshot shows, okay, we've run our LSP enrollment. We powered on the operations manager, and it's enrolled in Lighthouse. It gets automatically detected and reconciled with our network design. So now you see the top arrow there. I know it's really small font. You can see the top arrow. That's the actual OM registered, and now it's online and it's talking to our CRC. The bottom arrow is the Cisco router. It's still working on a ZTP, so it hasn't enrolled yet. It hasn't got that connection to the OM or to our smart management fabric to be a reconciled device and be something in our inventory. So right now you can say it's going through the actual ZTP process. Okay, so now it went through its ZTP process and it gets enrolled. It gets enrolled and has its configuration, and it's reachable through the smart management fabric to all the way up to Lighthouse and to the CRC. And then once this happens, you know, we have the reconciled devices. We have a new updated reference design. Things are good. They run the diff. This is the diff utility, and the integrator can now ship it to site. So for this scene, okay, this is just a quick, you know, okay, we received it at site, we sent it out to Utah, and now the actual folks on site, they're gonna unbox the rack's installed, they're gonna unbox it, cable it, power it up, and then what'll happen is the whole rack will go through the same process minus the ZTP of the router, obviously, because all that stuff's configured. But it'll call home the Lighthouse. The OM will call home the Lighthouse. It'll check itself against the CRC and say everything's okay or everything's not okay, and run a diff to see, if there's missing devices or whatnot. So let's say it gets there and a power cable became loose on the router. So once you do that diff, it'll say, hey, this thing's not online, this router's not online, and it'll alert the NOC or whoever's managing this from the home office to say, hey, we need to send a tech out to go check this out. And you might have that, you can have that censored, you could check your port logs, your serial port logs, or you can have sensors for your power to see, okay, this power is gone. So the tech goes out and he resolves it. Once he resolves it, it'll go through the discovery and diff process again, and then hopefully you'll get that final look where everything is in the reconciled devices. And then your operational site's up. All right, so next scenario we're going through is an operational scenario. So, everything is up and running, everything's fine, and your security organization says, hey, we want you to do an audit, a vulnerability audit at this location, at your Acme co-location in Utah. So what we've done is we've set up in our web app, or our Lighthouse web app, the ability to check for vulnerabilities, specifically based off of the version of software you're running, and do a CVE check. So, you can see the walkthrough here. We conduct a vulnerability audit. Yes.
These are checked against CVEs only, or is it checked against like release?
So in this app, we're just doing CVEs.
only.
Yeah, but yeah, see what you're getting at. That would be, but I mean, that's something you could set up. It's just, in our case, just for the.
You got to have something to look at.
Exactly. So, Andy will walk through this, but the user prompts the AI to look for CVE impacts. The AI goes and looks at, checks some websites, and then it'll output, and then you can generate a report.
Okay, very good. So there's a web application. The show in this part of the demo here, here's our discovered resource catalog. These are all the devices that are actually in the network. You can see over on the right-hand side here, we have this check button associated with each of the devices. So if I press this, the application is going to reach out, in this case, to an online Cisco CVE application that they've kindly hosted for us, or not for us, for customers in general, but we're making use of that. And it's pulled down a list of the current vulnerabilities for this device based on the model of equipment and the installed firmware version that we found on the device. So this is nice, right? You can click through to this, and you can see the information that Cisco's provided. That's fine. But we're going to bring a little bit of AI to this part of the demonstration here. We've got this button at the top which says Analyze with AI. If we click on that, what the web application does is it uploads this list of vulnerabilities accompanied with a suitable prompt, and it sends that information to, in this case, it's using ChatGTP. And we're going to get back an executive summary based on these CVEs, and it will be displayed here in a moment.
Is it simply a summary of the CVEs, or is it the summary relevant to my config?
At the moment, it's just based on the CVEs, yes. But that's a great idea, right? We're just putting our toe in the water, seeing what works, what doesn't. How can we take this forward? This is something that we could do fairly easily for the demo today. So here's an executive summary. It's showing us the most critical vulnerabilities and the areas of the product that are affected. There's some statistical information about the distribution and the type of the severity, and what sorts of vulnerabilities have been published for this device. There's a summary of the affected components, and there's some suggested mitigation steps. These are the Cisco CLI commands that the network administrator could run in an attempt to maybe mitigate some of these issues. And it's also reordered the vulnerabilities for us. So, this can be exported as a PDF or as a CSV file. So, you can take action with that. There we go. It's coming up in numbers. So that gives you a task list that you could then work through later and take care of these or pass them off to your SecOps people. And we can do the same thing for Opengear devices as well. I choose one here, just choose this one. We get a different list of vulnerabilities. We click Analyze with AI. We're going to get a different set of commands. It is aware of the model and the manufacturer of the equipment, so it's going to suggest commands that are more appropriate or appropriate to the command line interface for this particular equipment. And you can click through these again. There we go. Okay, so we've got some vulnerabilities identified, prioritized, and then some suggested mitigation steps. Now, this is one of the interesting things with AI is you don't always get consistent and predictable results. In this case, it didn't propose any command line commands that we could actually use to address some of these. Sometimes it does, sometimes it doesn't. So that may be an area for us to focus on to improve the prompt and maybe train the AI, train the LLM to be able to get more meaningful results back from it. So that's the CVE portion of the demo. Now we want to talk about log analytics. So one of the mechanisms that we built into the web application is the ability to stream log data from the connected resources and from the Opengear console servers. Take all that data and ingest it into a vector database. So you can see some of the logs streaming in here in a few seconds. It updates. And then what we can do is we can do analytics against those logs. So we can ask it questions here. We're going to give it a fairly generic question, a prompt here, and see what it can come back to us with. Now, this particular AI implementation is running on-prem, so the logs are not sent out to a cloud-hosted portal. This is all running using an Olama model. Some of the other features in the application were built using ChatGTP. And this is just part of our process to kind of explore the capabilities of these different agentic AI systems.
Question,
Yes.
Josh from Diversified.
Mhm.
When you mentioned where you're running the llama model, is that something that's in the Lighthouse system, right? And that's where you're correlating all of the data, or this log data is getting sent to?
Not yet. No, we've got our Lighthouse system. This application is hosted on AWS.
Okay.
So it's private cloud, but we didn't take the step of integrating all of this as a Lighthouse feature set. So it's done some analytics on the logs. It says appears to be from a Linux system, some interface issues there, some error messages, interfaces not found. We have deliberately set up a port flapping issue in the logs. And when we run this on some occasions, depending on what log data is in scope, right at the point where the analysis is done, you will get information back from agentic AI about those port flapping issues.
Yeah, essentially what we have, we set up a fail case basically in our demo lab in Utah. So we have a OM 2248 that's sitting there and it's connected to a Cisco 3750. And I basically create a spanning tree loop on the 3750. We have port logging on for the OM, on the OM for that specific serial port. So what's happening is the Cisco 3750 is sending his logs to the OM. Actually, it's just reading his console. And those characters are basically getting forwarded up to through Lighthouse to our LLM, as if you look at the view logs. So it's a way so you can go, the scenarios being, hey, we have a network that's kind of going slow. We have a complaint. You're at a knock and users are complaining, hey, this is going slow. And in order to not have to read through all these different logs, tons of log data, we've set up where you can just go query, hey, we want to look for some potential network issues and the AI helps you out by analyzing those logs and looking for those logs for you. So it says interface flapping. So this is, that's not quite correct. But if you read the actual, text there, it says, hey, we have this Mac flap notif that we're getting, which, if anyone's used a 3750 or an older Catalyst switch, that's basically the, Mac's jumping between ports. It's a spanning tree loop. And that enables you to go, hey, I can go look at this, and it specifies, this is on FA, what is it, 4037 and 4038. So then a tech can go down and, hey, I'm going to go look at this port. I'm going to unplug that cable or whatever device it is.
I mean, I would, Sam from WWT, I would caution you against inferring that, because that's standard functional behavior. If a wireless client moves from one,
Sure.
you're going to get a Mac flap notif, right?
Right.
And so how do you differentiate between proper Mac flap notice and inferring that there's a loop? Right? Those are some pretty dramatically different.
Yeah. So
arrive at.
So one of the things when we were doing this is looking at is you have to be able to train your AI or your model to know what to look for, and ours is not trained up just because of the memory context and things like that. So in the instance for the demo, we were just we want to create we want to pick something out, and yeah, you're right, but it's just a way. But yeah, you have to train that so you don't get those erroneous messages, like it said interface flapping, which is completely different from Mac flapping, right? Or port flapping. It's different from Mac flapping. So yeah, that's we pretty much walked through our demo. I mean, any questions, I guess, at this point?
Question, Josh, do you have the ability to swap out the model choice that you have? You mentioned Llama earlier. I was curious if there's an ability or a roadmap or feature that could open that up for us bringing other models in, or an API to some private AI model that we've got running.
We do. We actually had a drop-down selector in the web application that you could use to choose the model, and we just pulled down 6 or 7 of them. We took that out for the demo just to keep the focus. But yeah, that's a great thought, and that's something that we were playing with ourselves just to get exposure and experience to the capabilities of the different models. And they're not all created equal, right? You get better results with one for some things, better results with another.
But these models are models that you're running. You couldn't tie them into.
Yeah, that was my second part of my question is, if we were running a private AI cluster and we had our own models trained on our own data, right? How could we have that network model being pulled from the API into?
Yeah, as long as those integration points exist, right? It's not terribly hard to set up API keys and tokens and whatever else you need, and be able to make use of a customer's on-prem AI system, private AI. Sure.
Perfect. Thank you.
Yeah, thanks for coming through here. And I think we just want to open up to any other questions at this particular juncture. I think there's a couple of key things that sometimes it's hard to demo this stuff in watching the early pieces. But in essence, you're almost taking the equivalence of a crayon drawing, being able to ingest that, turn it into data that represents the actual network, and then in real time be able to update that inventory. And there's a lot of things you can do with that, whether it's security vulnerabilities or whether it's other compliance things, tying that into other compliance tools. And then really the next steps, throughout this, there's a lot you can do with the CVEs that we didn't, show here either. And some of those comments I know were coming out. When you get into really analyzing log data, a lot more training that has to go on in there. And, I think even from an LLM perspective, in retrospect, looking back, we'd probably change, that out. Now, I do think it's important if we can run locally. Sometimes you don't want to expose your data outside to the wider universe. As Andy was saying, it doesn't really matter. Lighthouse runs in AWS. What we just showed here, we just happen to have the AI stuff running in a different instance of AWS. I think it's actually GPU based, isn't it? Versus where we're running Lighthouse. So in essence, that's all, even though it's public cloud, that's still kind of a private deployment of that. And it's because you may not want to push that data outside of your own perimeter. So hopefully this generated some thoughts, gives you an idea of some things that we're thinking about.
Do you have any roadmap? Because it feels like this is early development, right? Like along some features and capabilities you showed here today, are there areas of interest that you haven't developed yet that you're looking at around these AI capabilities that you can share?
Yeah, I think we've taken, the production system, as Andy was saying, and we're just taking advantage of, the APIs, the interfaces on that to be able to extract them, build, the agents that we've showed you, and go, all right, how kind of exploring the feasibility of it both technically as well as how would it work from a business perspective. So yes, this is very early kind of developmental work. Conceptually, you could do the same thing yourself. There was nothing that would stop anyone from going out and taking Opengear's production system and doing what we just did here. I don't think that's how it'll probably be consumed, to your point, by most folks. They don't, they'd probably, want it more packaged than that. And so as we experiment with it more and more, kind of hone in on it, then it'll get more real, really, for the product management team.
Okay.